Hello, everyone. I'm calling today to join you for the National Environmental Science Program Climate Systems Hub seminar series. Today, I'll be leading a group talking to you about climate adaptation for threatened species in protected places. My name's Alistair Hobday. You'll hear today from Sarah Boulter, Claire Mason, Valentina Mella, Chris Purnell and Andy Williams. And I am calling from Nipaluna, Hobart, which is a traditional home of the Muanina people. And I acknowledge Tasmanian Aboriginal people all across this land who have got an unbroken and ongoing commitment to country. I hope in the places that you're calling in from, you also have that same appreciation and recognition of the long period of land stewardship by Indigenous people across Australia. And increasingly with climate change and rapid change happening right across the country, everybody needs to be working together to understand how past practices can help us manage better into the future. This is what our future looks like. At the moment, in about 2023, we're looking at a range of futures depending on how much greenhouse gases is emitted into the atmosphere. Depending on how much greenhouse gases are emitted, we'll see somewhere between around perhaps 1.5 degrees of warming up to 5 degrees of warming. And that's the real imperative for societies around the world, how to make a really rapid energy transition. For the next 10 years, though, regardless of what we do, we've really got what's called locked-in climate change. And regardless of which scenario we end up on, you'll see that all of those lines in the period that I've coloured in grey there have the same increase in temperature. It's the same with decrease in rainfall. It's the same as change in sea ice. We're really locked in. And so that means we've got pretty high certainty that we need to do some things very differently than we have in the past. The two calls to action are around mitigation and adaptation. And it's at a whole of government level and the international commitments that mitigation is being tackled. And mitigation is the main game around reducing greenhouse gas emission. For a while, adaptation, which is addressing local impacts of climate change, was seen as a distraction to mitigation. And some people thought that if we dealt seriously with adaptation, it would be a distraction to mitigation. I can't really see that holding any water anymore. And both of these things are desperately needed. We need the long game of mitigation, and we need real on-ground action now, particularly to help species, habitats, and people cope with historical change that's already causing impacts. And when we think about climate change, we often look to the far future, but it's really clear that we're already experiencing these changes now. The things we'll talk about in this webinar are really showing how interventions are being used to increase the flexibility that we have into the future. And it's really important, particularly for natural systems, that we're doing this work early and hard. And that's because in these kind of analyses that we see from the International Panel on Climate Change, the Intergovernmental Panel on Climate Change, that different sectors will be hit differently by warming. And these plots are called the burning embers plots. And they show for different amounts of temperature rise when different sectors of the economy or the natural environment will be impacted. And with biodiversity, the impacts from a warming world come in pretty seriously at about 1 or 2 degrees of warming. If we dial into that one, for example, with terrestrial and freshwater ecosystems, biodiversity loss, tree mortality, wildfires, all of those graphs turn from white, perhaps a safe operating space, into orange and red between about 1.5 and 2 degrees. The same is true of oceanic systems. So we will not see coping with natural systems if governments accept, say, 3 degrees of warming. And that's why adaptation will be critical. Again, this is not coming a long time in the future. Just this year, we're seeing really dramatic and I think step changes in what the planet's experiencing. In the ocean, for example, on the left-hand side, this plot shows since 1981, what were average temperatures that are experienced in the ocean over the course of a year, every one of those grey lines. The current year is shown in black. And we are seeing such rapid difference and departure from previous conditions that it is so dramatic, we lack words to describe it. On the planet, on the right-hand side, the same thing. Air temperatures are warmer than they have ever been in terms of human evolution and human existence on the planet. So climate change is not coming to us in the future, it's here now. We're already seeing that those impacts suggest that adaptation won't be able to save everything or help everything adapt. And what's the evidence for that? Extinction. We're losing some species. Sea level rise, for example, with the Brambles K melamise has led to the loss of a species there. We're seeing coral bleaching. We're seeing animals moving around. And in the ocean where I often work, we're seeing 60% of marine species are experiencing range change already. And our projections are this pressure is going to continue. So in the face of this uncertainty, the kind of things we have to do is to monitor, respond, and be fast. And particularly with helping species and ecosystems adapt, we have got a framework for which we can begin to operate and make decisions. We use something like an adaptation framework to help us think about where these options are. And with adaptation, what we're trying to do is reduce vulnerability. And a simple definition of vulnerability is the potential to be damaged or altered or resist change. And our work of scientists over the past decade or so have shown there are many places in which we can help with adaptation. For example, you could reduce exposure to climate change with interventions such as translocation, habitat modification, shading, or other engineering that means that even if the temperature is getting hotter, animals don't receive that exposure. The second set of levers are around sensitivity. Animals may still experience the hotter temperatures, but if there was supplemental feeding or habitat modification or disease treatment, they're just less sensitive to those warmer environments. So exposure is don't go on holiday to a hot place. Sensitivity is take your sunscreen. And finally, we can increase their adaptive capacity by reducing other stresses. And that's often the traditional work of conservation, reducing bycatch, eradicating pests, managing predators. So amongst that suite of levers, there are dozens and dozens of things that people can do in order to reduce vulnerability. And those are generally called adaptations or interventions. We've typically designed these adaptations and interventions for the long term though, end of century. What can we do to prepare things for the year 2100? And a really good example is planting trees that will mature over the next 50 years with a variety that can cope with warmer temperatures. But we're not going to see a climate arrive in a linear fashion. We're going to see along the way floods, droughts, heat waves, cold spells, extreme events that mean the road to the future is a bumpy one. What does that mean for conservation? It particularly means that we have to pay attention to these short-term bumps on the road. And a really influential paper for me looked at hundreds of interventions around Australia in these different places where indicated with a dot on these maps. And the findings of the authors were that between 30 and 80% of interventions were impacted by short-term weather outcomes. So while we're planning for the long-term future, understanding what seasonal and interannual variability will be doing is really important for getting to the long game. So not only does intervention have to think about the year 2100 or 2300, it has to think about navigating this year. It's a really big El Nino year. What will that mean for our interventions? So what about the people that are responsible for these interventions? We've had to change the way that we think as well. I was brought up as a conservation biologist, and at that time, the view was that we would be acting as curators. If we can create protected areas, if we can put fences around things, we'll just be able to preserve and protect. So at the beginning of my career, our profession acted as curators. In the second slide just there, in the medium term, objectives become pretty important. And I think we've seen a shift towards people behaving as ecologists and analysts of the landscape, designing experiments, looking at testing different options, and on the basis of that, making their management decisions. Finally, which I thought would be more like decades away, but I think is really here now, in the long term, today, we have to really think about how we're going to engineer our environments. Which species will we facilitate? What predator control will we do? Will we even move things around and create novel assemblages? And I think this is going to be a tough place for many in conservation and land managers, is that we like to be curators. Let's not play God, but somewhere to the right-hand side here is engineers. We're starting to be a bit like the hand of God into these many, many systems. And I don't think that's a comfortable place for everyone at the moment. So the aim of this project then is to co-develop practical products and decision support for conservation managers who are seeking to do these interventions that can be both attentive to short-term variation and long-term outcome, so that we really help Australia's biodiversity succeed in a very, very challenging period of time. While I've talked about climate change as one of the stresses, these managers are also having to deal with disease, invasive species, population pressures, land use changes that are not related to climate, but climate's one of the really strong trajectories that makes everything more difficult at the moment. Our project has 3 goals. The first is to help identify adaptation options. These again have to be options that can help you navigate both short and long-term change. In order to help navigate that short-term change, we're providing environmental forecasts about the climate, particularly around the next 3 to 6 months, that will help managers think about, should I use a strategy that will help cope with a wet year, even though my long-term strategy is for dry conditions? Are there particular interventions that will be very valuable to me this year because we're going to see not much water in the landscape? And that will offer me opportunities to do, for example, predator control more efficiently. And finally, we're going to develop frameworks and decision trees that should lift adaptation planning in general and allow people to do a better job of linking short-term outcomes with the long-term gain that we need to solve also. We're doing this work with with a large number of stakeholders around Australia. And in order to think about how we work with these different groups, think of this as a bullseye plot. On the left-hand side, in the middle of the bullseye, are people that we're working closely with in testing intervention options, providing situational reports on upcoming climate conditions and looking at how they affect different outcomes. We hope that some of the products we're producing will be widely adopted over the course of the project by what we call shovel-ready mature conservation managers and planners. And then finally, at the outer ring are stakeholders who we hope will be able to use the products that we're doing well after the project is finished. And we have a range of approaches of hitting those things on the right-hand side, one of which is case studies. And this is the way that we're working with particular on-ground groups to improve conservation planning and the interventions that are available. Some of the case studies that we've been working with are illustrated on this map. And over the course of our project, we hope to engage with between 10 and 12 case studies. The ones in green show that we've already got 7 of those underway. We're in the planning phase with another 1 and in discussions with another 3 or 4. And these case studies span people who are dealing with individual species challenges in the face of climate, landscapes and communities, and then also the boundaries around protected places that include everything. Species intervention is the easiest, protected places is the hardest. Just think of the scale and the complexity that you deal with. So given that the goals of the project, I hope I've shared why we have such an imperative for doing interventions and helping the species and habitats to adapt to this pressure that climate is bringing to Australia. Part of the motivation is to connect people and share what's going on around the place. And in the Climate Systems Hub of the National Environmental Science Program, Professor Sarah Boulter is what's called the Adaptation Initiative Lead. And she has a particular responsibility to look at how adaptation is rolling out across the entire National Environmental Science Program. And I have great pleasure in saying, Sarah, please take over from me with the advancing of the slides, and welcome. And I'm really looking forward to you formally launching one of the great products that this team has made. Thank you, Sarah.
Great, thanks, Alistair. I just have to say that I am pressing the button, Tani, and it is not advancing. Thank you. So just putting in place where this project sits, going up to a higher level. So the National Environmental Science Program invests in 2021 in 4 hubs. The Climate Systems Hub that this project sits in, Resilient Landscapes Hub, the Marine and Coast Hub, the Sustainable Communities and Waste Hub. And this project that Alistair is leading, Project 2.7, is sitting within the Climate Systems Hub. But it's worth saying that what I'm trying to do, as Alistair is foreshadowed, is really trying to bring adaptation across projects, across all of the hub, but also try and harvest information and make connections across the different hubs, because what we understand about adaptation is that it really is a complex challenge. And I think that that's particularly so for conservation managers. I wanted to sort of say, you know, in prefacing launching the calendar, we recognise that trying to do adaptation in the conservation space is particularly challenging. There's a lot of experimentation. Sorry, hang on. I just realised I need to go to the slide with the where our project sits. So what I wanted to say about this project was that this project sits amongst a whole range of projects, and we are bringing information together from those range of projects to deliver this approach to land managers to try and support them through adaptation. What I was going to say around actually implementing adaptation, it's very challenging. It often involves a considerable amount of experimentation, trial and error. And so we've really taken an approach with this project of sharing ideas. So through our connections with the other projects, but also connections with other stakeholders, trying to foster that learning and sharing of ideas. So we're really looking to invest in a community of practice, if you like, but we also wanted to be able to celebrate some of the often quiet work that's going on across Australia that really, doesn't get enough recognition. And that led us last year to come up with the idea of developing a calendar as a communication tool. So the 2023 calendar, it curates 11 different case studies or exemplars of what people are doing in thinking about adaptation interventions, some of them quite unique and experimental, and we put them together into a calendar. And we really have to, give a lot of thanks to Claire for pulling that one together last year. We distributed 200 copies of the calendar, and it was immensely successful. We found externally for the Climate Systems Hub, there was a lot of interest and a lot of excitement and a lot of praise around the calendar. We sent a copy to the Climate Minister, Tanya Pliberzek, and she wrote a lovely letter thanking us for that. So we were able to, capture attention at all sorts of scales. But for the project, we were also able to use it as a tool to engage with 7 of the feature months. So they were not projects that we'd necessarily engaged with through the project previously, but we were able to re-engage with them as stakeholders to test some of the outputs of the project. We've also, able to sort of snowball distributions. So we have lists of who we've distributed to more closely and who they've then passed that on to really understand the reach of the calendar. It's been so successful, we've been a little bit more ambitious this year. And so once again, the team has pulled together another 11 features, plus the spare is our project. And they're really highlighting exemplars of adaptation intervention. Each month is telling just one story from an amazing body of work that we're seeing through this project. And so I guess at this point, it's my pleasure to sort of officially launch the calendar. And I'm going to pass back to Claire, who will give you a little bit of a taster. We can't give out all the detail of the calendar just yet, but a little taster of what we did and how we did that. So thanks, Claire.
Thank you, Sarah. Thank you, Alistair, for setting up the context for the calendar. My role now is to give you a little bit more insight into the calendar and then introduce 3 of our calendar features who are going to do an in-depth dive into their projects that are featured in the calendar. And then we'll open for Q&A. So the audience can ask questions of our calendar features, as well as the 3 talking today. Most of the other calendar features are in the audience. So yeah, feel free to use the Q&A function throughout this to get going on the discussion. So yeah, I am a postdoc at CSIRO, and I'm working full-time on this project in the NESP Climate Systems Hub. So as Sarah mentioned, we're really excited to officially launch the 2024 calendar. We've featured 11 inspiring projects from across Australia and have featured both species-focused projects and ones with a place and ecosystem focus. So what we're including in the calendar is a bit of a story of this climate adaptation journey, a quote from the person on the ground with lessons they have learnt from undertaking the action, the huge amount of organisations involved in some of these projects. It's often a very collaborative effort. And we've also got a QR code to find out more. So on the Climate Systems Hub website, we've got links to more information for all of the projects we've featured. So in 2024, our 11 projects span coast to coast. And as I said, 3 of these projects you'll hear about in more detail. But as a quick overview, this year we've got quite a few coastal projects that are tackling inundation from sea level rise and the challenges that brings, including Blue Heart on the Sunshine Coast, Salt Marsh Restoration Project down in Tassie, which is a huge collaborative project with NRM South, and also Lake Meelup in the Peel Yargarup Ramsar site in Western Australia, who we've worked with through this project in a bit more detail. We've also got some species focused projects. So in South Australia, some threatened species work with artificial habitat for endangered pygmy blue tongues and endangered kangaroo island dunarts. And in the arid zone, sandhill dunarts, and trying to plan for this species losing habitat with extreme wildfire from climate change and also invasive buffel grass. And then, of course, some down in East Gippsland and West Gippsland catchment management authorities, the frog bogs, a project with the Love Our Lakes program in Greening Australia, and they're creating bespoke tailor-made frog habitats to help out frogs in drier times. And we've also got a project from our sister Nest Hub in the Resilient Landscapes Hub, based at the University of Newcastle, which is looking at safe havens and where they should be across Australia under climate change. So fences and islands to protect predator susceptible species. So over the 2 years of this calendar project, we've showcased 22 inspiring examples of on-ground climate adaptation around Australia. Sharing these projects we feel is really important because it moves this cutting edge field forward by sharing what we're doing, what's working, what's not working. And we also hope that it will provide hope and camaraderie to conservation around Australia, where it can often get quite challenging and depressing, I guess, when, you know, we're up against some pretty huge challenges. So I'd like to acknowledge and graciously thank all these organisations and projects for sharing their stories and their time and enthusiasm for contributing to the calendar. And yeah, most of these people are in the audience, so please add any questions in the chat as we go. So I'll put these up and Tanya will be popping all of this in the chat as well. But if you'd like to have a look at our 2023 calendar, there's a link there where you can download the PDF. And we also have a website for links for all the further information. And I can see Tanya's already put up the link for the 2024 calendar as well. So please feel free to share and have a look all at those links. So quickly back to our project at the moment. So as you can see from all these projects, there's many ways to intervene in the face of climate change. You can do one long-term thing once, one thing many times, so deploying artificial nests every year. You can do many different things many times. Interventions can be done in the face of emergency, or they can be planned or preemptive. And so as part of this project, we're really interested in this pointy end. So I'll just talk you through this schematic we've been using briefly. So this, from left to right, scans a continuum of conservation activity that contributes to climate change adaptation. So of course, at the broadest end, there's the strategy and underpinning, policy, research, planning, monitoring. And then as you move across, the specificity of the climate response increases. So you've got broad overarching threat abatement, so very traditional conservation that we've been doing for a long time, that links into that adaptive capacity that Alistair mentioned before. Then you have interventions that are on ground and physically manipulating the system. And finally, down the pointy end, we have defined this as climate adaptation interventions. So conservation activities that specifically address a climate change vulnerability and or incorporates climate information. And so as part of, and just to talk you through an example, Alistair and I have both worked on shy albatross in this space, an endemic Tasmanian albatross species. And so, for example, a broad action would be reducing bycatch in fishery industries or designate an MPA. An intervention would be a disease treatment to increase chick survival. And the climate adaptation intervention would be deploying artificial nests to improve breeding success in years with challenging weather conditions. So that's just a little example to explain that. So as part of our project, we are collating all these climate adaptation interventions from around Australia and ones we find from the world as well in an adaptation catalogue for conservation. This is the kind of information we're collecting. So what's being targeted, the types of intervention categories and what threat is being abated. And we're also building in all those extra considerations around doing an intervention, such as costs, social acceptability, risk, the evidence. So if anyone in the audience or you know of anyone that is doing some climate adaptation on the ground, we'd love to include this in the adaptation catalogue for conservation. We are collating this in a searchable database. It will be publicly available by the end of next year. And that's my email. I'm collating all these actions. So please get in touch so we can include your work. Oops. And finally, before I pass over to the guests, to inform the design and delivery of the database and how we showcase these examples of climate adaptation, we're running a survey. This link will be provided in the chat and at the end as well. But please, if you have 7 minutes and would be using this information about wanting to do adaptation in your system, please fill out our survey. Now, it is my great pleasure to introduce 3 of our calendar features who are going to give a 5-minute overview of their work. I'm going to start with Dr. Valentina Mella, who's a lecturer at the University of Sydney, and her work on drinking water for koalas in the landscape is featured in March in our calendar. So I'm going to pass over to Valentina now.
Thank you, Claire. Welcome, everyone. Thank you so much for having me. I guess you can see I work with koalas. I'm a behavioral ecologist, and I started this work in 2016. The population of koalas that I work with is an inland population that lives in the Liverpool Plains in New South Wales. So these animals are facing quite a dry and hot climate, especially in summer, but even in winter, the precipitation and rainfall has diminished majorly. And from 2016 to 2019, they had a pretty severe drought, and local landowners started to flag that they thought water was to blame for some of the declines that we had started seeing in this population. We had at least a 25% decrease in the number of koalas that lived in this area just during one summer and during one heat event. And this is an area where originally the population was thriving, and it was actually the only koala population in New South Wales that was increasing in number compared to the rest of New South Wales. So that sort of spiked our interest. We started going to the Liverpool Plains regularly, And we decided that we would attempt giving water to koalas. I'm actually from Italy, so when I moved to Australia, what I learned is that koalas don't drink, and they don't need to drink much. And guess what? I've discovered that that's not true. So we see them drinking naturally during rain. They lick the trunk of the trees and to get the water. But what we've discovered with this project is that they actually access free water throughout the year, even when it's cool. Of course, the frequency and the amount of water that they drink depends on how hot and dry the weather is, but they do drink all year around. So it is not true that they don't need to drink, and it is not true that only sick animals need to drink. These animals deal with climate change. They don't have a lot of ways to deal with climate change and with the warming climate. They mainly use evaporative cooling to keep the temperature down, which means they have to pant a lot. And by panting, they lose a lot of water. So in order to be able to keep the temperature down, they have to access free water to be able to pant more. So it's a bit of a vicious cycle for them. And what we've done, we set up these water stations in the environment and just waited to see if they were using them. And it was a great success. And these stations were used not only by koalas, but by gliders, the sugar gliders, the feta gliders, the squirrel gliders. We got python going to these drinking stations. We got goannas. We have designed this type of station specifically to try to limit the access to feral predators. You see that it's usually set up in a tree where there are no low branches, because we found that with low branches, both foxes and cats were able to access the water stations, and we definitely didn't want to help them. So we changed the design to make it as hard as possible. And I'm very pleased to say that we have not recorded access by feral predators since we changed the design. And this project was very successful, also thanks to the fact that wires picked up on this and offered to distribute for free these drinking stations all throughout Australia to private landowners that had threatened species or endangered species on their land, and that they were worried about the effect of climate change. So we have so far determined that the risk of disease and of predation at these stations is low. We've done bacterial analysis and obviously monitor the presence of predator to ensure that we were not spreading diseases, especially chlamydiosis, obviously. And we have literally just got the results of the other day that demonstrate that koalas that access the drinkers are actually much better hydrated and have better blood parameters than koalas that don't access the drinkers. So I guess this is a very good example of how a very simple solution can help in the face of climate change. And I'm not sure how I go with time, but if, you know, I can talk forever, so you got to stop me.
Thank you, Valentina.
No problem.
That was great. So yeah, you can find out more about Valentina's work using the QR code on the calendar. And then, yeah, please add anything in the Q&A. And Valentina, I'm sure, will be able to type an answer, or we'll have time at the end to discuss. Thank you very much, Valentina. My next, I'm now going to introduce Chris Purnell, who is the Wetland Birds Program Manager for BirdLife Australia, and will be sharing with us about floating roosts for migratory shorebirds. Thank you, Chris.
Thank you. G'day, I'm Chris Purnell, and I'm coming to you from Wurundjeri land down here in Melbourne, Heidelberg Heights. I'll be talking about something that goes a little bit further than Australia. So there's migratory shorebirds, which we share the privilege of managing and enjoying with 23 different countries up and down the East Asian Australasian flyway. So they spend a non-breeding time in Australia, as you might know. So they've just arrived and they breed up in the Palearctic. the Arctic. And to make these journeys of, over 12,000 kilometres each year in one way, they need to refuel along the flyway. Now, we get 36 species in Australia, and around 2 million birds hit our shores this time of year. And they've travelled through some really highly populated areas for humans. Over half of the human population lives along the East Asian Australasian flyway. So there's enormous pressure on their habitats, and the story of decline and in these species, and they're really disproportionately represented in our threatened species listings, these shorebirds, and it's largely through habitat loss. So climate change is part of that habitat loss, and climate change affects them in other ways by shifting the availability of food in their breeding grounds and thawing out the peats in their northern breeding grounds. But the biggest habitat loss is in the Yellow Sea, and this is sort of the super pit stop for these birds, this huge low energy area, which is the coastlines of China, Korea, and North Korea. And as you can imagine, there's a lot of pressure on those coastlines. Similarly here, we're not free of the obligation and the problem. We share the problem and we share the solution. And a lot of our coastlines are highly impacted as well. You just have to look in Moreton Bay and areas like Toondah Harbour, which is a Ramsar site, which is increasingly in the news because it's under pressure from development. So I'll talk about my project and how we sought to make a novel attempt to try to restore some of the part of the habitat that these birds use. So these birds feed on the intertidal mudflats, which are only available for part of the day. As you can imagine, they not dictated by the day or the night, they're dictated by the tide. So when it's low tide, they're feeding out of the mudflats. When it's high tide, they get pushed up into a very thin supratidal site, or even the upper intertidal, where they rest and they roost, and they have to conserve their energy so they're in a positive energy balance once they move on, so they can make these huge journeys. And these little tiny areas of upper intertidal and supratidal habitat are the most threatened. As you can imagine, we use words like coastal squeeze. So where human activity and development's moving increasingly from the inland side and sometimes even onto the intertidal area, where huge reclamation projects, seawalls are built around and infilled and built on top of intertidal areas. So this coastal squeeze and the sea level rise is coming from the opposite direction. So increased storm surges washing away what we call roosting sites, these resting sites, and precluding birds from resting. So one site that we were working on in Korea, the most significant site in the Republic of Korea, the Kum Estuary and Sochon County, they were interested in us giving our perspectives as Australians as to how we can address habitat management there. And we looked at their roosting sites where these birds were resting at high tide, and 5 of the 7 most significant resting sites where 72,000 of these birds filter through every year. And 5 of the 7 sites where they rely on resting were underwater for over 50% of the high tides. So for over 50% of the high tides, they had to squeeze into 2 roosting sites, or what more commonly happened is that they circled around in the sky. And so this is 30,000 birds circling around waiting for the tide to go down, and they're just burning fuel. So they're like planes in a holding pattern. And what we thought, we can look at some more traditional roosts options. Like what we do is building terraformed roosts, but they're subject to go underwater. They're expensive. They're hard to get the permits for. They're temporary. They require maintenance. They can get covered in vegetation, accessed by feral predators. So we were really scratching our heads. And I remembered a photo I saw of an oyster farm in Merimbula in the lakes. And there was a critically endangered eastern curlew roosting on one of these oyster bags floating up and down. And it went up with the tide and down with the tide. So it was available for 24 hours. And so I packed up a bottle of wine and went up to speak with the oyster farmers, sampled some oysters, and we got these roosts developed. So this is a trial, and it's only really an emergency intervention. So when other coastal managers have explored and exhausted every other attempt to restore roosts in their area and reduce pressures, they might seek to deploy some of these. And it doesn't really work on the population level. So the size that we're looking at now, we had birds, up to 500 birds in one roost, and they were absolutely at capacity on that one roost. So it doesn't work when we're talking about the thousands and tens of thousands of birds that are being affected by habitat loss. Now, we found that the water is the important bit. So these mesh bags, which are used for oyster farming, the mesh allows water to travel through, so they don't rock and move too badly in the ocean, and they're also resistant to really high energy monsoons, which they get in Korea. But the birds can importantly keep their feet wet, so they can thermoregulate. When it's really hot, they can keep their feet wet and they can keep cool. When it's really cool, the water has an insulative property as well. And so we put thermologgers on the bags, and we found that they had a really finite window of thermal heat that was being the birds were subjected to, whereas some of the rocky sites where birds were forced to roost on sea walls or piles of spoiled rock, they were really getting really hot and really cold. We also filled the bags with oyster shell to mimic what they were doing in the oyster reefs, the commercial oyster practices, and that provided opportunities for intertidal benthos to colonize the shells, and the birds can feed throughout the tide. We ended up with 55 species of water birds using the roosts, including critically endangered species. And we even had some of our resident shorebirds trying to nest on them in Ramsar sites down here in Victoria. Our next step is to phase out the plastics. So we're working with RMIT and Deakin University to look at things like marine ply and bamboos and reducing the carbon footprint, making it more sustainable and circular, and also encouraging people in the Yellow Sea to use more sustainable practices for farming oysters, because this could have a mutual benefit in those communities. We're looking at potato starch as degradable materials, so we're not contributing microplastics. All these will last 20 years in a marine environment. They're not really what we want to be putting in the ocean. And to that point, I don't really want to, this is a project where I don't actually want to see these out there. And, similar to the last story, we want to be able to fix the underlying problem and I don't want to ever see a floating roost. These are really the last intervention that you want to investigate, because it's only really emergency response and should only be employed temporarily while other factors are being addressed in natural roosts. So I think that's probably all I've got to say. Thanks, Claire.
Thank you so much, Chris. Huge thank you. What an inspiring project, and yeah, it's great to have you here sharing this work with everyone. For our last calendar feature, we have Andy Williams from DBCA, a projects officer, working on Ashfield Flats. So I've seen in the chat, one of the questions was around what are landscape-based climate adaptation interventions, and we've had 2 species interventions, and this is a great example of a landscape one. So Andy, thanks so much for joining us, and I look forward to hearing about Ashfield Flats. Thank you.
Hi, hello folks. Yeah, Andy Williams, broadcasting live from Wajak Noongar Budja, which is Perth, WA. Talking about Ashfield Flats, which is a place that is really significant to the history of Perth. It is one of the largest remaining river flats that we have over here. And so if you're familiar with Perth or the southwest of Australia, you might be aware that the predominant landform in the metro area is Swan Coastal Plain. And through urbanization, infill had obviously taken place to increase the population density. It didn't actually happen in Ashfield Flats. So you still have this kind of remnant feature of what Perth would have been like pre-colonization. Although it's obviously been modified to some extent, but it does allow for some really unique hydrological conditions that are favorable for the subtropical and temperate coastal salt marsh, which is the TEC that you see in the image on the left there. That's actually an image taken from an escarpment that looks over the flats, a lovely lookout that was a community project. And yeah, as you're saying, it is quite a it's definitely a picturesque area, but it's right on the urban fringe. So it's facing pressures not only from climate change, and I'll get into that, but it's also talking about a landscape. It is highly used by the local community. Yeah, and I'll get into that in a second. But yeah, essentially, you've got these historical land uses that have happened around the site for whatever reason in our wisdom previously. These sites along the river, the Derby Yerrigan, were often used for dumping rubbish, dumping asbestos. There's a massive open drain that actually bisects this river flat, and all these historical land uses now we're left to, I guess, remediate or mitigate the impacts as we're starting to feel the pressures from things like climate change. So in 2019, there was a 2-year hydrological study conducted to quantify some of these pressures, the groundwater issues, the lifespan of the open drain, and the effects that might have on the TEC there. The hydro study essentially, identified by 2030, the level of inundation that would be seen on the site would become would start destabilizing these favorable conditions for the TEC, and start inundating higher ground further towards the east of the site. And so the hypothesis was that the TEC would start to migrate further east. So, there was this one imperative to assist with that migration of the TEC, but taking a landscape view, and the reason why it is the Ashfield Flats master plan that we've been working on is, there's so many different factors going on here. I mentioned groundwater, I mentioned some of this historic use, which kind of limits the amount of digging into the ground that we can do. There's a lot of acid sulfate soil. So, we're not looking at any massive big earthwork kind of interventions, really just a softer touch, facilitating that migration and establishing conservation areas through things like fencing, I guess, what we were speaking about previously with these adaptation, the curation, like where is this TEC going to move to, and how can we, one, lay out the welcome mat for it, but also protect it into the future. And how do we balance those imperatives of conservation alongside the huge community of amenity that is found on the site? This is one of those stories where you really have to take the community along for the ride during our consultation. So, and sorry, to give you an image, where the flats are, it's kind of bordered by some higher ground, and that hosts a riverside kind of path, and then you've got the river on the other side of that path, and that foreshore path, which is highly used by the community, is described as, the main street of Ashfield. People were talking about their experiences during COVID in our consultation, saying, this was one of the few places where I could get outside and connect with people. It saved me during COVID. Those kinds of sentiments were coming out of the community. So understanding how any kind of intervention that would be taking place for the protection of the TEC, but even to adapt these community amenities going in the face of these pressures, climate change pressures like sea level rise, really had to be taken into consideration. I've just gotten the word. Yeah, so essentially, it's bringing in all of these considerations and balancing out a range of different qualities: community, amenity, environmental, and really it's just stage one, the master plan. Given the huge importance that it has to the community, we really do need to make sure that they will be supportive of what's going to happen there. And so, yeah, I think the consultation is still open. So if you're in the Perth area, and I can recommend going to the Last Crumb Bakery in Bassendean, which is just next door, go for a little walk around Asheville Flats. It's a beautiful site, and feel free to add to the consultation, which is open until the 8th of December. Thank you.
Thank you so much, Andy. That was a great overview of the Ashfield Flats, and really similar to a lot of the groups that we're working with and people we're talking to about the complexity of things changing and values as things change. Thanks again to Valentina, Chris and Andy for giving us an insight into some of the projects that are featured in this year's calendar. I'm just gonna, so we've got about, Alistair, I might pass on over to you for the Q&A at the end.
Beauty, thank you everyone. I've been watching the chat. I will distill some of the questions, and Valentina, I'll ask you one first, please. When we do interventions, often it's efficiently done when we can aggregate animals in the landscape, because then we can get more of them. How did you consider things like disease risk that could be an unanticipated consequence of concentrating koalas around a water source? And in general, for adaptation intervention, what's your view about the trade-offs between, some benefit at risk?
So yes, part of the work that we do in the Liverpool Plains is disease monitoring. Obviously, chlamydiosis is a huge issue for koalas. So we are lucky enough to have huge resources at the University of Sydney with the Koala Health Hub. So we had veterinarians with us. All the koalas in a radius of about 20 kilometers of the water stations were actually microchipped. We microchipped over 400 koalas and were all health checked. Most of them had disease or clinical signs or tested positive for chlamydiosis. So what we did was we monitored the disease at the actual stations. So we took regular swabs of the drinkers, and we also tested the quality of the water to ensure not only that there was no contamination with chlamydiosis itself, but also that there was no other bacterial or fungal disease that koalas can be, affected by. And we're very lucky that chlamydiosis does not survive really well in the environment. So there was no risk of transmission of chlamydiosis unless two animals came into contact. But koalas are not very social animals. So what we found through the monitoring, which is still going today, so from 2016 to 2023, I think I can probably count maybe 5 occasions where there has been 2 koalas at the drinkers, and usually the interactions are one arrives and the other one goes, and so there is no direct contact between the animals. So the bigger risk, and the one that we were more worried about, was predation. And we have found with our original design that we had foxes climbing trees, and that the foxes were literally going there because they could smell other animals. So they were less keen to use the water to drink. They were using it, but they were very investigative at the actual stations and following animals up the tree if they could. So we straight away changed the design, and we made it impossible to access the water from the ground for an animal like a fox, which anyway needs some kind of support when they climb. I would say that the risk of cats climbing those stations still exists. but they are now over 4 meters above ground, and if climbing, it's not easy to come back down, I guess. So it would have to really be worthwhile for them to climb up. So we have not recorded any feral predator at the station since we have changed the design. And if the people that set up the stations follow our indications and they don't set it up where there's low bearing branches, then we feel pretty safe that the trade-off between predation and access to water is sort of kept under control. And of course, the main issue for those koalas living in that environment is disease and climate change. And so this was a way to address one of the issues, I guess.
Yeah, thank you.
No problem.
Thank you. Chris, you did describe the seabird rafts as an intervention of last resort. Sea level rise is going to be with us for another 300 years, even if we switch off greenhouse gases today. So how would you confront the scaling up challenge? And I guess I'd preface that by saying the area where we've seen their habitat lost has seen incredible human engineering to turn it into a different landscape. What stops us from doing at-scale engineering to return opportunities for migratory birds?
Yeah, well, thanks. Absolutely. It's admirable, almost the ingenuity that they've taken to reclaim. It's called reclamation because they're reclaiming land from the sea. It's a bad word, but they have put seawalls that 6 times, cordoning off 6 times the amount of the water that holds in Sydney Harbour. It takes half an hour to drive along these seawalls, and I think that the amount of habitat loss that's been, particularly within the LOC that we've seen, will not necessarily be redressed as quickly as it was instated, but at least there is a recognition that of the requirement to stop. So within China and Korea in particular, they've just recently been successful in a serial listing for UNESCO World Heritage Sites for the importance of the significance of their mudflats. So they have enforced legislation against further reclamation and development of any more sites. So I've been at conferences over there where I've posed the question, well, what about climate change? What about sea level rise? And I was met with the response that in the LOC they don't have sea level rise. They do have sea level rise, but not as extreme as outside of that large embayment. But everywhere we'll have to, as plan for retreat. And so we're working, particularly in Australia, in a lot of these projects around blue carbon and retreat habitat. So modelling where is the path of least resistance for these habitats and enabling space. So when we map shorebird habitat, significant shorebird habitat, we are also identifying where that can hopefully retreat or where it can be replicated. So these are very small interventions, and I think that even this floating roost, even though it doesn't really address threatened species at the population level because they're relatively small, and I don't want to see hectares of these out there, it does because it's novel and people can see it very visibly and it's a bit fun. It raises the knowledge of the importance of these roost sites in the zeitgeist. So people look at these things and they try to understand the issues which we're facing.
Thanks, Chris. Andy, I have a question to you about how much information we need to have before we do landscape scale restoration. But because we're running out of time, Andy, can you give me a yes/no about, do you think we can do landscape restoration without understanding all of the patterns and processes around species and ecosystems in that landscape? Can we get in there and be gung-ho? Yes or no?
No, I don't think so.
All righty, we will have a longer discussion. Thank you very much for joining us, everyone who's not in a room with me today. Please keep being positive about adaptation and the opportunities we do have to make sure we have great biodiversity outcomes for Australia. It will mean more intervention. It will mean questioning the way we do things, and it will mean putting species into places that they haven't been before. But the alternative is not worth considering. Go about your conservation business, your management, your policy work, and do the best you can for Australia. Thanks, everyone. Goodbye.